Inside the stack. Inside the stack looks something like this. Recall that your base pointer is responsible for saving your position inside of a stack. And so with respect to the stack, the base pointer is like its home page. It says, this is where I am. So everything works around the perspective of the stack pointer. And so when we call the function add with two parameters, 8 and 4, it looks something like this. Now, as you recall, on the stack, it's increased by 4. So 4, 4, 4, 4. And everything works from a relative point of view of the base pointer, because it needs to be worked from the point of view of the base pointer, because the stack pointer is always changing when something is pushed onto and off of the stack. So this is always changing. So we need the base pointer to be a keepsake to tell us where we are from a stack frame. So with this function, you need to know that the base pointer goes up from here, it goes up towards higher memory, and from here it goes lower to lower memory. And so to access things above the base pointer, we need to add, and to access things below the base pointer, we need to subtract. And you recognize that things that are above the base pointer are the return address of the caller function, in this case main, and the parameters passed to a function. So here we need to recognize that to access the 4 inside this function, we need to do the base pointer plus 8. Why 8? Because here we have 4 and 4. So offset of 8 bytes up in stack memory to access the first parameter. And the second parameter is likewise 4, 8, and 12 to access the number 8 from the stack. And recognize that the brackets indicate that we're accessing memory. And conversely, to access local variables on a stack, you need to subtract going lower in memory. So we're going to subtract 4. Why 4? Because everything is offset by 4 bytes. So in assembly, in total, everything looks like this. You need to set up your function stack frame by saving the base pointer, by saving the old base pointer of the caller function. In this case, it's going to be main that we're saving, the main stack frame base pointer. And we're going to create our new one by moving the new value of the stack pointer into the base pointer. And we're going to reserve 16 bytes of memory for local variables. 16 bytes can give you 4 integers, for example. And after we're done setting it up, we destroy the stack frame by using leave and return. Conversely, you can also have pop, EBP, and then return to destroy the stack frame. And here is where the actual body of the function lies. From here, you can access the stack frame that you already set up using here. It's important to recognize that the stack frame is at a different memory location than the body of your function. The body of a function is located in your code section or your text section, while the stack frame is located in your stack frame. In your stack segment of your code.